Welcome to today's presentation on the functional components of a computer system. Computers have become an integral part of our lives, and understanding their internal components will help us appreciate how they function. Today, we'll break down each key component and its role in the system. A computer system has four essential functional components. First is the input unit. This allows the user to provide data and instructions to the system. Central processing unit, known as the brain of the computer, it processes data and executes instructions. Memory unit, this stores data temporarily or permanently. Then output unit, this presents processed information in a user-friendly format. Each of these components is interconnected, working in harmony to transform raw data into useful output. Now, input unit. The input unit acts as the gateway for data to enter the computer system. It allows the user to communicate with the computer by providing data and commands. Input devices convert this data into a format the computer can understand, usually binary code. Some commonly used input devices include keyboard. This is the most basic and widely used input device. It allows users to input text, numbers, and commands. Mouse. This device enables point and click navigation, making it essential for graphical user interfaces. A scanner converts physical documents into digital format. For example, scanning a printed photograph creates a digital image. Then microphone records audio as input, useful in applications like video conferencing or voice to text systems. Other devices include game controllers, webcams, and specialized input tools like barcode readers. Central processing unit. The CPU, often referred to as the computer's brain, executes instructions and processes data. It performs calculations, logical operations, and decision-making processes based on the instructions it receives. It is the core component responsible for the computer's overall performance. Now coming to the components, the CPU is divided into three main parts: arithmetic logic unit, control unit, and registers. Arithmetic logic unit performs all arithmetic calculations like addition, subtraction, and multiplication, as well as logical comparisons like greater than or equal to. Then control unit, this manages the flow of data between the CPU, memory, and other hardware. It acts as a coordinator, ensuring every part of the computer system works in synchronization. Then registers, these are small high-speed storage locations within the CPU. Registers hold intermediate data, instructions, or results for quick access during processing. Then the memory unit. The memory unit is where data and instructions are stored temporarily or permanently. Memory serves as a critical bridge between the input and output processes. The speed and capacity of memory significantly influence the system's performance. We have basically two types of memory. One is primary memory and another one is secondary memory. Primary memory types include RAM, random access memory, ROM, read-only memory, and cache memory. A random access memory, RAM, is volatile memory that is used to temporarily store data that is actively being used by the CPU. For example, when you open a file, it's loaded into RAM. Then ROM, this non-volatile memory, contains essential instructions like the bootloader, which helps start the computer. It cannot be altered during regular operation. Then cache memory, this is a smaller, faster type of memory located close to the CPU. It stores frequently accessed data to speed up processing. For instance, cache memory might hold instructions for an ongoing task. Then the output unit. After data is processed, the output unit displays the results in a format that users can understand. It serves as the final stage in the data processing cycle, converting binary code back into text, images, or sound. It displays or produces simply the result of computations. Some examples of output devices include Visual Display Unit (VDU). This includes monitors which display text, images, and video. Modern monitors like LCD and LED screens offer high-resolution output. Printers convert digital documents into physical copies. Printers can be categorized into types like inkjet, laser, and 3D printers. Then we have plotters. These are specialized printers used for creating large-scale designs like architectural blueprints. Other devices include speakers which produce audio and projectors for large-scale visual displays. Interconnectivity of functional units. Here is how the functional components interact. The input unit captures data and sends it to the memory unit or CPU. The CPU processes the data using the memory unit for temporary storage. Once processing is complete, the output unit displays or outputs the results. This seamless flow ensures data is transformed efficiently and accurately. To summarize, the input unit gathers data and commands. The CPU processes this data and executes instructions. The memory unit temporarily or permanently stores data. The output unit presents the processed information. These components work together to handle complex tasks in a fraction of a second. Importance of functional units. Functional components form the backbone of every computer system. Understanding these units is crucial for IT professionals, engineers, and anyone working with computers. They ensure efficient data processing and allow computers to perform tasks across industries like healthcare, education, and finance. In conclusion, computers are powerful because of their well-organized functional components. Each unit plays a distinct role but depends on the others to function effectively. Mastering this knowledge is the first step to understanding advanced computing systems. That wraps up our discussion on the functional components of a computer system. Thank you.